If a shark bites an internet cable at the bottom of the ocean, how do you fix it? Above all, how do you find out where the cable broke in thousands of miles of ocean? From this video to the entire YouTube, TikTok, Instagram, and even the entire global tech system today is connected to each other through the internet, and 99% of the entire internet traffic passes through the hidden cables at the bottom of the ocean. A highway of traffic that we use every day but cannot see. Welcome back to Past Empires videos. The network of undersea cables is so large that they connect all continents. These cables are laid at a maximum depth of 8,000 meters, where the pressure is 5,300 kg per square inch. This is like putting the weight of an African elephant on the smallest toe of a human foot. The smallest part of the undersea cable is passing under the Black Sea between Azerbaijan and Turkmenistan with a length of about 300 kilometers, and the largest part is 6,600 kilometers long, which is called the Mariana Cable. It starts from Virginia Beach in the United States, passes through the dark depths of the Atlantic Ocean, and ends at Bilbao in Spain. If we talk about the cables laid in all the oceans of the world, the total length of all of them is more than 1.4 million kilometers. So much so that if these cables were wrapped around all the planets and their moons in our solar system, there would still be enough cable left to circle the Earth again. Now it is obvious that laying such long cables at a depth of 8,000 meters in the ocean is not a trivial task. Laying just 1 kilometer of submarine cable costs a maximum of $2.5 million. Now you can estimate for yourself how much it would have cost to lay 1.4 million kilometers of cable, and why was there a need to do all this when in today's era the same work can be done wirelessly with the help of satellites. In fact, there are 493 submarine cables in the whole world. Each cable can carry 4 terabytes of data, and that too in just 1 second. Think of it this way, 80 million people can stream a 4K movie simultaneously on just one cable, and there are 493 such cables. On the contrary, if a satellite does the same job, only 24,000 people can watch the same 4K movie on one satellite at the same time. We will see that to meet the demands of the people, more and more satellites will have to be installed, which will be more expensive, and maintenance will also be more expensive than submarine cables. Satellite maintenance is more costly and difficult than submarine cables. If for some reason a major fault occurs in a satellite, it will cost $400 million to replace it. This is why laying millions of kilometers of cable under the sea is easier than satellite or wireless connectivity. Data worth millions of kiloids is traveling in this undersea highway all the time. This means that this highway will also be quite wide, meaning that these cables will be thicker than a normal domestic fiber optic cable. But this is not the case. At first glance, this yellow and black cable is as thick as a hose pipe, but in reality, the fiber optic cable passing through it is as thin as a hair. Now, the question arises that how is so much data sent through such a thin wire? This hair-sized wire is called the core of the fiber optic, which is made of glass. Or it is made of plastic, through which light passes, which travels in small packets of data. First, the data in the computer is converted from an electrical signal to a light signal with the help of a transmitter. The transmitter does this work using laser light or LED. This light signal is transmitted or sent in the form of pulses, which has only 2 parts, ones and zeros. The light pulse indicates 1, and when there is no pulse, it indicates 0. It is the job of the core to carry these pulses from one place to another between which the light travels. There is a layer outside this core called cladding, and this layer prevents the light from leaving the core. If the light tries to leave the core, the cladding bounces it back inside the core. This process is called total internal reflection. Now at a greater distance, this light signal becomes weak, for which a repeater is installed after every 100 kilometers, which boosts the light signal. To fulfill this part, a layer of copper is placed on top of the core and cladding, in which a DC current of 10,000 volts is sent because there is no power source in the middle of the ocean. So the current passing through the copper layer to power these amplifiers, the fiber optic cable, is used to transmit multiple signals simultaneously. This technique is called wavelength division multiplexing, WDM. Light of different colors is passed through the fiber optic at the same time, and each color of light contains separate data packets. As you know, the speed of light is 1079 million kilometers per hour, which means that this data reaches from one place to another at the speed of light in the blink of an eye. When it reaches thousands of kilometers away, this data is converted into an electrical signal again with the help of a photodiode or photodetector, and then the computer or mobile device reconstructs it again and takes it into graphics or any other form. In addition to the core plating and copper layer, The reason why the submarine cable is thick is because there are 7 more layers on top of it, whose job is to protect the cable from the extreme pressure of water. However, despite this cable can be damaged by earthquakes, shark attacks, and volcanic eruptions under the sea. But the biggest reason for damage to submarine cables is fishing. Some vessels hunt fish living on the bottom of the sea with a trawl wire which has a rope attached to it, which is directly connected to the vessel. This trawl wire is sent to the bottom and dragged on the ocean floor, and then the fish get caught in it. When this trawl wire is accidentally thrown at the place of the submarine cable, the cable gets damaged due to dragging. Now here all of you must have one question in your mind, that if submarine cables get damaged in such a vast and deserted seabed, then how are they repaired? Repairing is a matter of later, but first of all, how is the location of the thousands of kilometers of wire pinpointed? Let us tell you here that today's modern submarine cables are 1 inch thick and 1 kilometer of wire weighs about 1400 kg, that is a sedan car. For installation in the sea, thousands of kilometers of such wires are installed in one piece on the seabed with the help of special ships. After thorough research, when a specific area is selected, large rolls of wire are loaded into ships and brought to that location. A special robotic machine that is capable of walking on the seafloor is used to dig a meter deep into the floor, and at the same time the cable is laid in it. This is a very slow process that needs to be done very carefully. It is estimated that it took about 2 years to install the 6,600 kilometer cable between the US and Europe. When the wire in one vessel runs out, a second vessel loaded with cable is called in, and the corner of the first wire is connected to the new wire and the laying work is continued. The biggest obstacle in this whole work is the weather. There are strong winds in the Atlantic Ocean 365 days a year, and when these winds take the form of a hurricane, no one can stop them. In addition, there are often Category 1 hurricanes in the Atlantic Ocean. Due to hurricanes or strong storms, the installation work is paused for several days until the weather clears. Now, if the installation work itself is so difficult, think about how difficult the repair work will be. There are data centers at both endpoints of the submarine cable, those who monitor the activity of the cable 24/7. As soon as the connection between the two is broken, it only means that the cable under the sea has broken. To find out exactly where the damage has occurred, a special device called an optical time domain reflectometer is used. This device sends a light pulse from both ends, and because the cable is broken, that light pulse bounces back. How long did the returning pulse take to return, and how much signal strength is left is estimated to determine exactly how many kilometers the damage occurred in the cable. This process is done from both ends, and it is verified that the location of both is the same or not. Now the DC supply from both ends, that is the current left in the cable, is turned off and ROVs are sent to the bottom of the sea at this location. With the help of ROVs, the cable is first physically inspected, and then the cable is taken out and brought to the vessel above. That part of the cable that if it is damaged, it is cut and another piece is inserted into it. Since the fiber optic core is made of glass, this work has to be done very carefully so that one glass is connected to the other as if it were in one piece. This process is called splicing. If the cable is short or the sea bottom is very low, first one part is lifted up, another extra wire is connected to it and laid down again. Then the same process is done on the other end of the broken wire. Benefits of submarine fiber optic cable: how does it work? About installation and repair, you may have got the answer to many of your questions. I hope you will like and share this video of past empires. Thank you very much for your loving comments. I will see you in the next wonderful video.